Well, so we're here with Tony Tang from Team Cayote here at the TITC in Bangkok 2026. Tony, first of all, how is it going so far and how much do you enjoy being at this very iconic place in the world of RC?
Yeah. You know, this is the first time here I'm at TITC, but I would say it's amazing. I've never been such a friendly and, it's quite an experience.
Yeah, especially when we look on the importance of the race. 320 entries from all over the world in all these spectacular racing classes. The racing in the modified class is spectacular, and also in the open brushless class, where many guys also are using the Cayote motors.
Yes. I think that's why we are here. We are here to support the team, and we are here to provide everyone equal chance to compete in their class.
Yeah, I mean, we can see already here on your table many different things. Can you explain us a little bit what you are doing with a motor when it's brand new out of the box before the customer or the team driver gets it to use on track?
Of course, because here we have a brand new motor freshly from the factory. We trust our factory, but as you cannot step into the same river, there's no paper that's exactly the same, right? So what we do is we actually open up every single motor. And we will check for different parameters. And if the motor is not up to the standard, we are not going to give it to our customers or to give to our team drivers. Okay.
Okay, so it means you will just double check everything and make all the important measurements, which we now will take a look on.
So here's the example, right? I will just show you what we are doing in this supporting area. So basically, the first thing we need to do is we need to check the balanceness of the stators, like the internal resistance. So we can just open it up. Have to be more careful with the sensor part. Yeah. So kind of slowly open it up to make sure we don't damage the sensors. And then we took the rotor out. This should be stored in really safe place. Otherwise, the magnetic field is too strong, so it starts to attract random metal pieces. If you have a collide, then the rotor is gone. Okay. So we use this Fenton meter for check for the internal resistance, because it's a Y connection, so that's one of the ground section, and you can check for each pole. Wow. This one is really a good one, right? Because you see very even numbers from each of the contact point. And I believe that the rule here is higher than 18. So like 9.4, 9.5 times 2 is close to 19, or something very close to the RIS standard. So the second thing we do is actually we have this magnetic checker. Okay, let's see, we have to put the rotor away, otherwise. So let it calibrate. So we put in the rotor, and what we do is we're gonna mark one side. Let's see here, okay. All right, 55. So this is the maximum rating of the rotor, right? And now we're just kind of looking for the other side. If this is the north, then that will be the south part. So slowly we rotate, and you can see this rotor is really a perfect example. It has identical numbers from both sides.
So that means that this checker is checking kind of also the magnet,
yes,
the strength, or the...
Exactly. Not just the strength, but also for the symmetry of the south and north pole. So after I think everything's fine, we're just going to put it together. Okay, so basically, because we all have a special sized rotor, So the normal tool, the one that we used to have, doesn't work.
Okay.
So you have to be very, very careful with the magnetic when you slide slowly into the can. Okay.
Yeah.
So that way nothing get damaged. And just reverse the process when we get the sensor board. Okay. And okay. So the next step is to fit the shims because we wanted the magnetic field to be very close to the sensor, but see, for example, you're having a very small gap between the Hall effect sensors and the magnetic stone. That way, every time when the rotor passes through, it gets a correct reading. If it's too far away, then the readings will be off.
Okay.
So this is actually very important for the boosting for the 13.5 class because our boosting setting is based on RPM, and the timing decision is based on the sensor precision. So this is very important. If the rotor is not shimmed properly, it starts to oscillating like this. So this will actually create inconsistent reading for the sensors, and eventually it will kind of destroy the performance.
Okay, so that's really interesting to hear about these kind of things you need to take care about, especially with the rotor and everything. And now when you install everything back into the case, then you will also check how many shims you need for the perfect gap.
Yes, exactly. So basically, I already know I need a lot of shims for this one. So I will just take all those 0.3s for now, and some 0.2. You can see it's still a little bit below the surface of this conductor ring. So let's take a little bit more.
Yeah, sometimes when you talk to customers and they report that they have taken their motor apart, and they sometimes have problems with bringing all the parts back together again. So it's really important to be so careful when opening the motor.
Yes, it is. It's actually a very precise thing that you have to check. Okay, now we have a little bit too much, right?
Yeah.
So you can see there's a gap. So we have to take out maybe. Okay. Okay, so still tight. One more.
So you want a little bit of play then in the rotor.
Really just a very small gap. So that will ensure your rotor have some free space to,
to maybe also not get blocked when the motor gets super hot, and maybe the parts will change a little
bit. Now you can check. This is the gap we're looking for.
Yeah, so it just feels like a couple of tenths.
Yeah, just kind of hold it up and down. Up and down, you can see a very, very tiny little movement, like about 0.1 for the shim. So we make sure the rotor is always in the right position. Okay?
Okay, and now it's time to just put the 3 main screws back through the case. When you tighten the screws, how much are you tightening them?
That's actually a very good question, because we only have 3 screws. So what we do is I only use the small diameter of the screwdriver at this point. So you just kind of rotate until you hit, even you just hit a little bit resistance, you stop. Okay, then you switch to another one. You do the same thing, resistance, stop. Okay, resistance, you stop. Then you just keep on shifting to the next and try to add a little bit force.
So as similar as possible on all the 3 screws, to not just put the case in a wrong position.
You don't want to crack the plate. You want it to be very steady, but still you don't want any angles. That will destroy the bearings, and also it will create problems for the sensors. Okay, so now the motor is reassembled. What we do is we put it on the modelizer. this tiny little guy will tell us a lot of information actually. Here, okay, let's see. So the first page, we will have the RPM, we will have the kV numbers, and then we'll have the testing voltage, and then we will have the timing angle, the deviation of all three-phase timing angle, and also the symmetry of the magnetic field. Okay, and that's for each Hall effect sensor.
Okay.
That's the ratings.
So a lot of values which you clearly have to understand when you work with such a device. So, but this is the good thing for customers who maybe don't own such a motor tester, that they know, okay, I buy a certain motor and it's hopefully already adjusted perfectly or almost close to perfection by the factory.
Okay, so now we run the motor. Okay, so you will get the ratings as I just mentioned. You have now you have the kV number, and you have the timing angle. You have the deviation of the timing angle. You see, this is a really good rotor that shows 0.3 degrees of deviation, which is like the north and the south poles. They are almost behind each other, like back to back. Okay. So here, normally for this motor, we run about 44 degrees of timing. So
you basically set it up on the case of the motor, but then you double check with the device.
Yes, exactly. So you can see here we have 44 degrees of timing angle being set up to the 1 decimal. Almost perfect. Okay. So that's how we prepared each motor for our racers.
Yeah, so it's really, really interesting to hear all these insights from you, and especially to also see many customers already using the new stocky motor and also these kind of outlaw stuff here for these challenging track conditions here in Bangkok. Are you happy with the team performance so far as well?
Oh yeah, of course. We have one Japanese driver. He's currently sitting 4th place in the open boost class. And we have also some drivers, they are all in the A slot for the non-boost class. So I'm very happy about the result.
Okay, so thank you for the moment, Tony. It was super interesting to see all these kind of insights here from preparing a perfect race motor here from Team Cayote at the TITC in Bangkok.